method that predicts total project's duration is the critical path method, or CPM. CPM is an analysis technique with three main purposes: to calculate the project's finish date, to identify to what extent each activity in the schedule can slip without delaying the project, to identify the activities with the highest risk that cannot slip without changing the project finish date. To calculate the project's overall duration, the critical path method uses two calculations: forward pass calculation and backward pass calculation. In forward pass, the early start and early finish dates are calculated. In backward pass, the late start and late finish dates are calculated. But what is the early start, early finish, late start, and late finish? Early start, ES, is the earliest date a task can start. Early finish, EF, is the earliest date a task can be completed. Late start, LS, is the latest date a task can start without delaying the project end date. Late finish, LF, is the latest date a task can finish without delaying the project end date. To understand how the forward and backward path analysis calculate early start, early finish, late start, and late finish, let's look at a simple example. By assuming 0 days for the start milestone and 0 days for the start of activities A and D, what is the earliest time that activity A can be completed? Yes, 2 days, because activity A takes 2 days to complete. How about activity D? That's right, 5 days. What about activity B? Activities A and D are predecessors of activity B. It means that activity B cannot start until A and D is finished. The earliest time that activities A and D can finish is 5 days. So, the earliest time that activity B can start is 5 days. By continuing the forward pass calculation, you see that the earliest time that the project can be completed is 15 days. As you've examined the forward pass in the previous example, you've seen that the early start of an activity is the latest related early date of all its immediate predecessors. In other words, the early start of an activity is the maximum early start of its predecessors. For instance, if the early start of activity A's predecessors are 3, 10, and 9 days, the early start of activity A will be 10 days, taking the maximum early start of its predecessors. The early finish of an activity is its early start plus the duration. This is how the early start and early finish dates are calculated in the forward pass. Now let's examine the backward pass. For the backward pass, we start from the back or finish milestone, change the direction of arrows, and move backwards. In this example, the latest finish dates for the finish milestone is 15 days. When you move backwards from the finish milestone, what would be the latest finish date of activity F? Yes, you are right. It is 15 days. The late finish date for activity E is also 15 days. How about the late start date for activities E and F? For E, it is 15 days minus the duration of the activity, which is 4. So, the late start for activity E is 11 days. Following the same calculation, the late start for activity F is 13 days. Now, what is the late finish date for activity C? In the backward pass, activity C is dependent on activities E and F. So, the late finish of activity C is either 11 days or 13 days. If activity C finishes any time later than 11 days, activity E will exceed 15 days, which is the project completion date. So, on the backward pass, late finish of an activity is the minimum of all its related successors. As you've examined the backward pass in the previous example, you've seen that the late finish of an activity is the earliest related early date of all its immediate successors. In other words, the late finish of an activity is the minimum late finish of its successors. For example, if the late finish of activity A's successors are 3, 10, and 9 days, the late finish of activity A will be 3 days. taking the minimum late finish of its successors. The late start of an activity is its late finish minus the duration. This is how the late start and late finish dates are calculated in the backward pass. What is the purpose of backward pass and calculating late start and finish dates? Well, the purpose of backward pass is to find the float. What is the float? Float is the amount of time an activity can be delayed or lengthened. Float is also called slack. One of the most important floats in project scheduling is total float. Total float is the amount of time an activity can be delayed or extended without extending the overall project completion time. In the example that we calculated the early and finish dates, what is the total float for activity A? To help you answer this question, let me rephrase my question. What is the maximum available time for activity A to float without impacting the completion date? Let's check how much float is available for activity A. The earliest finish date of activity A is at day 2. It happens when activity A starts immediately. However, activity A can start any time between day 0 and day 8. If activity A starts later than 8 days or lengthened more than 8 days, it will be completed later than day 10th. This will impact the succeeding activities and consequently the project's completion date. So, the maximum available time for activity A to float without impacting the completion date is 8 days. To convert this observation to formula, total float is late finish minus early start minus the duration. Now, tell me what the total float for activity B is. Well, it is 11 minus 5 minus 1. That is 5 days. Let's further analyze the total float formula. Total float is late finish minus early start minus duration. Do you remember what the early start plus duration is? Yes, it is early finish. So, another formula for the total float is late finish minus early finish. Can you extract any other formula for total float? Yes, you can. What is late finish minus duration? Right, it is late start. So another formula for total float is late start minus early start. Another important float in project scheduling is free float. Free float is the amount of time an activity can be delayed without delaying the early start date of its subsequent tasks. What is the free float of activity A? In other words, how much can activity A be delayed without having any impact on the early start of activity B? What would happen if activity A uses its maximum float? If A finishes on day 10, then B cannot start earlier than day 10. Therefore, if A uses its maximum float, then it will impact the early start of activity B. But to calculate the free float, we need to check how much activity A can float without changing the early start of activity B. The early start of activity B is 5 days. So, activity A should finish no later than 5 days to have no impact on activity B, right? It leaves room for 3 days float. Therefore, the free float for activity A is 3 days. As seen in the previous example, the free float formula is the early start of the earliest successor of an activity minus the early finish date of the activity. In this example, what is the free float of activity B? The free float of activity B is the early start of activity E, which is 11 days, minus the early finish of activity B, which is 6 days. So, Free float of activity B is 5 days. Now calculate the free float of activity C. What is your answer? 0? That's right. Activity C's successors are activities E and F with the early start of 11 days. So there is no room for activity C to float without impacting activities E and F. In other words, the free float of activity C is 0 days. Why are floats important in the critical path method? To answer this question, let me ask you another question. If an activity has a total float of 0, what does it mean? It means that there is no room for delay in that activity. If that activity is delayed or extended, then the overall project's completion date will be extended. In other words, that activity is a critical activity. Therefore, floats determine the criticality of an activity. Critical activities have the least amount of float. Floats determine the critical path. That's why floats are important in the critical path method. What is a critical path? The critical path is the path of activities that cannot be delayed without delaying the final date of the project. When an item is on critical path, it has 0 float. The critical path is the path with longest duration, and it is possible to have more than one critical path. In the example that we did the forward and backward pass, what is the critical path? What is the critical path? How did you answer this question? Well, you need to calculate the total float for each activity. The activities with 0 total float are on the critical path. What activities have 0 total float? Activities D, C, and E have 0 total float. Therefore, the critical path is start, D, C, E, finish. We mentioned previously that the critical path is the longest path. The longest path is the path with the longest duration. In this example, what is the length of the critical path? Yes, it is 15 days. Do you see any other path in this example that has longer duration than the critical path? Let's evaluate different paths in this example. One path is start to A, to B, to E, to finish. What is the duration of this path? Yes, 7 days. Another path is start to D, to B, to E, to finish. This path's duration is 10 days. Another path is start to D, to C, to F, to finish. The duration of this path is 13 days. As you can see, the critical path has the longest duration. That's why if an activity on the critical path is delayed, the entire project is delayed.